We will now begin our next presentation on MES Automated Controls Applied by the Barnes Group Advisors and Wabtec. We have with us Chelsea Cummings, Senior Advisor of the Barnes Group Advisors, and Jennifer Coyne, Additive Manufacturing Leader of Wabtec Corporation. Chelsea Cummings began her engineering career at Honeywell Aerospace, gaining experience in various roles, including additive manufacturing. Her AM experience focused on development of metal parts built on powder bed machines for aerospace applications. Her experience qualifying production parts for AM with the FAA at Honeywell led her to a role in new product engineering at Arconic, where she successfully qualified additively manufactured parts for aerospace production for a major aircraft manufacturer and others. Her work with various manufacturers for flight and space has honed her AM design skills for diverse applications. We also have Jennifer Coyne. She is the Global Additive Manufacturing Leader at Wabtec Corporation, where she oversees additive engineering, design, prototyping, and parts production for Wabtec's global additive manufacturing efforts. Since forming Wabtec's first additive manufacturing team, she has successfully led the launch of over 5 production additive parts and opened 3 labs in the US and India with a wide range of metals and polymers. Jennifer has 5 US patents, and most recently, she's been named the co-chair of ASTM Transportation Railway Heavy Equipment Applications Committee. Welcome to both of you.
Thanks, Andera.
Thank you. Just want to check and make sure. Oh, your screen is sharing. Awesome. And I will just hop in at the end to help you moderate Q&A.
Okay, perfect.
Thank you.
All right. Thanks, everyone, for tuning in. If you're able to tune into the last presentation, Zach gave us the perfect interlude. He said they're working with Google Docs, hope to move to Link 3D. So this is actually an examination of MES Automated Controls Applied to we're going to walk through the qualification process and also the production process. Full disclosure, we were not at all pressured by Link 3D to plug their product. It just so happens that Wabtec is a customer of theirs, and it seemed particularly relevant for this group and audience. So an overview, we're going to examine the piston cooling jet, PCJ for short, look at a case study of that and how MES aids process control. We're going to analyze the benefits to the part from early stages of qualification through production. We're going to summarize formerly manual with Google Docs, now automated with a full MES system implementations. We're going to review the MES outlook for process control moving forward, and then evaluate how MES answers certain questions of the DFMEA, certain failure modes, and then we'll go into Q&A. Jen, did you want to add anything for the overview?
No, go for it, Chelsea.
All right. So from qualification to production, the PCJ with AM particularly achieves 66% improved lead time and 25% cost improvement. So those are the benefits of AM. And the further that we can adapt to that process, the AM manufacturing process to the rest of the system, obviously the better, the more benefit that comes. So we're going to evaluate or the qualification process, how we've fractured it out is a multi-phase qualification from including machine, process, and part. So with the machine, we're looking that it meets basic production requirements, running test builds, and testing coupons as needed to prove that it fulfills its operational duty. Looking at the process, this considers the parameters that you put in to produce the consolidated material, and if you're at your general properties threshold. And then third is the part itself. So through a first article qualification, just like any other manufacturing process, AM has to undergo the same thing. It might look a little different with the build tracking, the types of coupons you're using, and then making sure you capture the process parameters that do give you that good first article. So we're going to walk through that and then how specifically the MES supports those details. So for qualification, the MES controls that apply to that, like I mentioned, first we'll go through our machine qualification, and this might look like a build of the full build volume. You might do that in some instances, or at least in the way that we've laid it out 3 times. You're going to thermally process all of your coupons just as you would your part or family of parts, and test those. So the MES controls that support that are the ability to record specific material and batch information to reference later. You can record your pass-fail criteria for your primary CTQs. In this case, we've established those to be strength, hardness, surface finish, density, and the likes of other common property requirements. So for the build process window, the process window basically is the based on the parameters that you're putting in, you'll get results, and depending on what your parameters were, they might achieve goodness, but your goodness could be right on the borderline. So working through that several different parameter sets and establishing data and from pass fail, but the best of the good. So you establish that border of your process window through your storage capacity in your MES, and then the supporting documentation uploaded by engineering, still that human factor, still that engineering analysis required. But basically it's all consolidated in one place where it can then be referenced for as you continue to improve your process. So what might have been nominated as the best parameter set, the goodest results, your first few rounds might change over time. And this allows you to have all of that information in one organized place where you can go back and reference it. So performing your static testing as coupons are ready, that's typical. Again, sort of that rolling input of information and data, helping narrow your target. And then in this part of the process, the qualification process, you're going to address your surface finish correlated data, most often correlated to fatigue. Currently, we have that data recording and storage capability. In the future, we'd like to see an analysis that can help predict those high-risk areas based on your build geometry simulations. So if you have your as-built fatigue at an angle that corresponds to a critical wall angle of your part in the build, then the correlation of that data and identifying exactly where that threshold is based on your build orientation. And then to further evaluate low-performing samples, so you can upload all your data, view it easily within your MES, and hopefully that would give you the broad visibility you need to quickly identify your low performers to go investigate further. And then Jen can talk more specifically about this, but within that field where you can click on a document, dig further and correlate the coupon to that piece of data, how you might continue to test and then capture and tag that data to a specific coupon. And then the design of your build. So this within the qualification might include part for part features before you get into the first article. So taking a typical geometry like the PCJ tube, building it at a series of aggressive to less aggressive build angles, evaluating your fatigue alongside accordingly, building out that part feature data. Also, once you're through that phase, moving on to your first article requirements. So translating that into a build specimen matrix, which then you can populate with your data to make correlations. You'll have unmistakable traceability, with all of your coupon labels within your MES. At this point will include powder capsules with each build. So if you need to go back and test your powder and get those properties, then it's all correlated and tagged to the same build. So ultimately, you have data being stored in an organized way that can be recalled based on your build, based on your coupon, based on your process set.
Yeah, so as Chelsea was saying, you know, we're walking you through a case study of a PCJ part, and part of that first part is understanding and qualifying your machine and your process, and then you move on to doing the same type of process for the actual build geometry. So this slide here is talking about applying those same controls now to the production process, and even a bit further than that, how you can then use that MES software for more things like production planning. So in the first part here, the MES data control, part of it is just having a line of sight and record of what the parts are being used for. For example, one of the first things I do when I put a part into the MES software is it designate the intended use of the part, or the build. Is it production, process repeatability, for example, how we would have tagged that last build file that Chelsea was talking about, mechanical testing, or maybe it's an end use part. Then you go through the build setup info. This is the intention. So the machine that I'm going to use, the operator, the build file, the time and start date of that build, the build simulation time, so what I expect it to take, the material. So this is where I'll record things like what I paid for that material particularly. So not just like a generic price, but what I might have paid for that batch. And I can tag that to a specific build. A batch number, so we can have material traceability. If there's some sort of issue that comes up later, we can have those tagged. That's actually kind of a very important feature that's specific to MES that we don't really have to worry about in some of the other MES systems. And expected usage, again, this is like the intention, not the actual. And then there's machine parameter sets. You can upload or tag, I guess, different machine parameter sets or other settings on your machine that sets up the build. Then you go into the build results. So this is now what happens. So recording things like yield, reason for failure, if there was one, actual material usage, actual build time, and being able to compare that and continue to iterate and get better on your predictions is also pretty important. So that's like the data control piece of MES and how we use it at Wabtec. But then there's also like the production planning piece. So you can do global scheduling. So you could select across a fleet of machines and similar or like machines and schedule them out based on availability and material availability at the same time. There's also digital travelers, which makes a lot of sense in a global environment as well. So you can track the build information and also the post-processing that's assigned to each one of those builds. We can track material inventory, also financial information such as PO numbers and price and quotes and actuals and margin, etc. And then things like machine downtime, utilization rate, scrap rate. That's something that I particularly use is on the analytics piece of this, which I'm not showing here, but on the analytics side of the MES software, understanding my usage of the machines is very important. So how much do I really use one machine versus the other? Why is that the case? Is it because one has a higher yield or one has more significant downtime or location-based or price-based, etc.? You know, you get to take a broad view of your fleet of AM machines and evaluate and make strategic decisions based on that.
So looking at the qual piece again, what used to be manual and what's now automated? What are we getting out of this transition we've made to the MES? And when I say manual, I'm going to make that synonymous with static. So it may have been you know, a more of a record rather than a live document, a living document. So build file iteration management. Before you, maybe you're keeping track of it in an Excel sheet, maybe you're keeping track of it in a Word sheet, maybe you're just simply looking at your PDM folder where you have your series of build file layouts saved with the revision and relying on that staying static. But the reality is those things could accidentally be changed. So it is important to have, beyond the revision control within your PDM, your MES can basically store the revision control of the build file iterations you went through and then tag them with the parameter sets that were used for them in a manner that's visible. So I think, again, circling back, what is the main benefit of MES? And it's really the visibility. All of these things can be controlled and manually tracked and inputted and saved and recorded and things with Google Docs or other tools, but the ability to call back the data together based on certain criteria and have it visualized for you, have it all in one place is really the key advantage. You get the same thing with material tracking. So with your powder batch traceability, maybe it was in a spreadsheet. I've lived that painful life before trying to take measurements, whether powder was weighed, and apply a use count, and then try and save the name of the file where the data for that powder is stored next to it in a spreadsheet, and then go find it somewhere else. That's all history when you have an automatic MES where the data is being made available to you. So maybe you still have to tell it what your material has experienced, maybe if it's had this many build hours on it or this many runs, depending on how you keep track of that. But now it's in one place. It can be categorized. You can visualize it. It's going to stay there. It's not actually accidentally going to get deleted if someone goes in and edits the file. And with that, you have your history of your iterative decision making. So making revisions and tracking revisions, or tracking why you made those revisions, I think are two different things. And based on the format with MES, simply with custom forms, you can add a custom form that where you could easily capture why you made the iterative decisions that you did. The CTQs, like we mentioned, you have your each of those for your machine, process, and part. Those can be categorized. Your data management at the qual level is really that of your initial build results and then which iteration you're on. And again, the process window capture. So you may be getting goodness, you may be getting good data, but with, as Jen mentioned, with your global view, maybe you're using one machine more than another, and maybe you're using the same parameter sets on both machines, but getting variable results, some failing on the other machine. And maybe your parameter set is right on the ragged edge of the process window, and that's what's causing you to fail. So even if your machine is maintained within the limits that it's supposed to be, it could just be that a more robust parameter set within a well-maintained machine is what gets you closer to the best optimal within your process window. And that goes with, and then a future look, maybe that could also capture operator insight into work instructions. I think it's implied with what I mentioned with the global view of machines, but perhaps making a custom form within the MES where the operator can then capture why they didn't choose the machine that was scheduled or the like.
So bringing it back to production, as we kind of switch back between qualification views and running a production part through this MES, system, you have this advantage, a further advantage of automating in production. I think it's even more critical when you talk about a production part to have automation. And we all know that because there's giant MES systems that definitely Wabtec uses, and others, I'm sure, large OEMs like us, we all use MES systems. So we're going to get into a little bit in the next slide here of why additive may need its own MES system or unique attributes at least. But in this one, taking a similar view, walking through a production part, what's manual and automated, that build revision management. So on here, there's we use what's called a digital part inventory here, and that's, you can actually kind of just recall all you can recall the STL file through a digital part inventory of exactly what was built and just reissue that same order through the system. So for example, I know we also have an MES and a PLM system through Team Center, but again, it doesn't necessarily show the visibility of all the build parameters plus the build file in the same location. So this is that build revision management and process control. And it also stores useful information like customer information and or routing information that's also critical to this production system. I mentioned material tracking, same thing here. It's important on your production parts because you want to make sure that you have traceability in case there is an issue in the end there. Hopefully, fingers crossed, there never is, but you need that visibility to go back if there is a reliability issue in the field or on a part later someday. Scheduling, I mentioned that before, but in particular, like just my experience with this is Wabtec's a pretty global company. We're in, I think, over 55 countries or something like that around the world. So I have to manage global demands. And when you're talking about a fleet of additive manufacturing machines, you can potentially have the same machine qualified for the same part in multiple locations, and having that scheduling view plus the location and use in mind is really useful. And I'm sure it's similar with any MES system, but route the parts where they need to go with a machine that's available. When we talk about CTQs, machine parts process, you can keep track of those and the results of those through the production system and through the results that you're storing in your MES system. So you're storing, it's a digital thread, right? You're storing what you built and the results of what you built per the CTQs that you've outlined. Process your inventory. That's that same thing of what is an easy way for me to report on number of production parts of a specific production part, what those results were, where they were, but it's just like a one stop shop for that kind of information. Responsible for it for a lot of you. And then just the statistics process control. So are we maintaining process control? I have a nifty little picture of the validation of this particular part because one of the requirements is a jet test. It's the function of the part is it throws oil inside a cylinder for cooling. And the main CTQ of this whole thing is that it cools the piston. So you do this jet test at the end. So what about also then tying your main CTQ or your validation results or your in process or your validation that's necessary on every part, whether it's X-ray or a functional test or something like that? What about tying that to the specific builds? And so you have the results of that particular build file, that particular material with that particular machine and operator and all of that going on to the actual results of the part itself. And you can see the thread being tied along the way and the usefulness of having that all in one place. So all possible, right? But used to be manual, I guess, is kind of the point there, Chelsea.
Yeah, and you made a good distinction that a lot of companies do have existing MES systems, but even still, they're driven into using the manual ones because it just doesn't quite apply. So that's a good distinction to make. A lot of big companies already have MES systems, but they still end up using spreadsheets and things to track things just because it's actually easier because of how not well adapted the existing system is.
To AM specifically, yeah. And that kind of leads into this next slide, right? And that's some of the specific needs. And I realize we're running low on time, so I'll go quickly here. But data collection and analytics, the AM specific needs of an MES versus maybe something that you already have at your company or you're familiar with. Powder batch traceability, virgin and reused tracking. Not saying necessarily all of this is like available on every additive MES system, but I think these are the needs of additive as an industry, particularly in powder bed, but I'm sure it applies with other modalities as well. Have an alternative way of describing it. Parameters, laser calibration to digital thread. We've got the post-processing needs, which are more AM specific, depowdering, heat trip, obviously, to almost all records. And then we go into production planning. We have that more distributed through scheduling software to schedule at multiple different places on the same qualified that way. And then feedstock tracking and qualification. Where I could see, I mean, I'm relatively new at using additive MES. We've implemented it because we saw a huge need in our company for it, but I can already see some things that would be helpful to have, and such as integration with real-time integration with the machine. So what I mean is like an actual connection where your machine is going back into your MES and telling it, I finished, I yielded X, or I had this build issue or error, and actually logs files automatically, so it's not like an uploading process. And then think about the accuracy that you would get with your build time estimates and all of that as well. So just real-time integration would be huge. And then I already talked about, we have a traditional MES system and traditional quality systems, but the integration of the additive one with the ones that we use at a larger scale isn't there yet, but that would be great. And then with common simulation softwares as well. And we are running out of time because she's popping up here, right?
Yes. Wow. Thank you so much. Our whole team is messaging each other, just blown away by this presentation. And this is really what Link3D's mission is to connect the digital thread for organizations like Wabtec. So thank you. We have quite a few questions in the Q&A. So let's try to hit a few of them before we run out of time. So first one by Laura, what percentage of time would you estimate is saved by transitioning to an MES versus manual?
You know, Chelsea and I were wanting to present on that and couldn't come up with good data. I don't know, honestly. I think before I try to quantify time, what I would say is the process before that was like email gen, you know? So honestly, it was just loss of data and lack of response. And I couldn't keep up with the demand in issuing quotes, etc. It just didn't make sense. So it's more about traceability and accountability for now. And then I hope eventually to be like, oh, we saved 10%. I don't know what that is though.
And we'll do one more question since we're a bit over time. So from Duncan, what section of the manufacturing execution system does the MES address when compared to other systems, such as your PLM, ERP, etc.? And does it extend to the higher level company process as well?
Yeah. So I talked about that a little bit in the end there. It doesn't yet. We're again really new to this, so maybe there's links that we could connect already that I don't even know about, but that's a IIT project in and of itself. So right now we're using it mostly for the simulation, which is unique to additive. And things like material, build time, scheduling, those are much more unique to additive and just work with our machines. Like, for example, the machines are preloaded if they're normal machines. So you can take that in and it automatically does a simulation for the machine that that's huge for us.
Thanks to both of you so much. Looking forward to connecting with you during the virtual networking as well.
Thank you.